today we will focus on InstructGPT. You may also hear about 3.5, like GPT 3.5, right? So InstructGPT is the extension of GPT-3, and then make it becomes like GPT 3.5, which is the major technology between the ChatGPT. The title for the original paper is Follow Instructions with Human Feedbacks. Before we dive into the details in the paper, let's look at the timeline from the transformer is created till the recent like GPT-4 model. So transformer paper, the attention is all you need, is proposed in 2017. It proposes the backbone transformer architecture, which is the foundation for all the following like BERT model, GPT model, and current LLM model. So this is the, I guess, the most important breakthrough paper that leads to all the recent innovations. And then in 2018, like 1 year later, GPT is proposed. So all of this series, like GPT related, is proposed by OpenAI. The first GPT-1 is proposed in a year later after transformer paper. And then it proposed the pre-train and fine-tune frameworks. And at that time, it's still like a small model, like just 100 million parameters. And then another more than half a year later, they published GPT-2. Now you see that the model size increased to 1.5 billion. This paper focused on the zero-shot performance, meaning that they are unsupervised models, meaning that you do not need to provide any like labels for specific tasks. These GPT models are kind of general models that can directly gives you the predictions based on your inputs. So this is the first attempt at that time that they show a promising direction, kind of can use the GPT as a general language model without any labels. And then they further improved the GPT-2 first, like they increased the model size, like closer to the LLM model size we know right now, to 175 billion parameters. And then they further improved the zero-shot performance, like without any labels, to a few shot learners. And they basically say that this time we still do not need like lots of training labels. We just need to provide a few examples in your prompt or in your input to the GPT model. And then the model can generalize based on those descriptions and a few examples. And then it shows improvement over the zero-shot, the GPT-2 model across a variety of tasks. And then I think this is again about almost a year, actually more than a year, almost 2 years. And then they proposed the InstructGPT, also named like GPT 3.5. So this model is the extension to GPT-3 model, but this model is mainly focused on like how we can further adapt the model to human preference. So basically, like for example, we need to make sure that the language is not toxic, right? And we need to make sure that the paragraph is matching what the humans instructions in the prompt. So basically, this is focusing on instruction, how you can train the model so that the model can directly follow the instruction you give to the model and give the desired output that human wants. So this paper, and again, the InstructGPT is the focus of this session. And then like about 9 months later, after they publish the InstructGPT paper, ChatGPT is released. So you can see like how ChatGPT is born, right? So it basically, it's based on all the prior progresses on the GPT threads. ChatGPT is just kind of an application, and the backbone technologies coming from all the previous developments. I think the major ones are the GPT-3 and then the InstructGPTs for the first version of ChatGPT. And then they further expand the GPT model to further first increase the size. So this is just a kind of estimate or a guess of how large the model is for GPT-4 over the internet. And GPT-4 model, they basically like further expanded to images. So the input can not only be text, they can also, you can also like create the model with the images and ask the model like what it is in the image, like what that person is doing in that image, or what objects are there in the images. So basically like input can become multi-model, including the text and the images. Okay, so this is the kind of the brief timeline and the history of the GPT developed by OpenAI. And today's session, we will focus on InstructGPT. And we also, we have given a session on GPT-3 in our last meetup. You can go to the event page and get the recording link from there. So before diving deep into InstructGPT, first let's look at some prerequisites. The first is the transformer. So you can look at this blog. So I have published a blog about step-by-step into transformer. I think it's very searchable on Google. So you can get the link and then you can have the full kind of a step-by-step walkthrough about the attention mechanism, about the transformer architecture. So overall, transformer is the encoder-decoder model, right? So encoder is basically tries to represent, like transform all your input sequence into a representation vectors, and as the input to the decoder, and the decoder will generate in the next token or generate in the next sequence of tokens based on your input. And then after the transformer is proposed, basically there are majorly two threads, BERT and GPT. So BERT is the bidirectional encoder representations. It's mainly using the encoder part of transformer, and the GPT is the generative pre-trained transformer, and it only uses the decoders in the transformer. And there's also some models such as the T5 or other models that are still use both encoders and decoders in the architecture. Since in this section, since we are focusing on the InstructGPT, so it is a GPT model, means that it's only using the decoder structures in the transformer architecture. Another major concept I want to briefly introduce is the pre-training concept and the fine-tuning concept. So the pre-training, you can think of the pre-training as of like the language understanding or the language so basically, if you mask some word, right? For example, if you this is your input paragraphs, and if you just randomly mask some words there, and your output will be just the recover the mask word. So if the model can correctly recover or predict the mask word, it means that it may have some basic language understanding, and it can understand the general language grammars, and also it can generate a good language paragraphs. So that's the purpose of pre-training. It's not associated with any task. It's fully focused on the language understanding and generation. And then we still need, we have lots of NLP tasks, right? Such as like language understanding, name entity recognition, or scored data set, like question answering data sets. And then the fine-tuning step is to further adapt the pre-trained model to specific downstream task. So this is kind of a very common framework, like in the NLP world, right? So first pre-train the model, or right now you can directly take a pre-trained model, and then you need to further fine-tune it. Fine-tune means you need to provide your input, output, and then update the model weights so that it can give good predictions for specific task. So here's just some examples of pre-training. Like the GPT pre-training is the next token prediction. So all the GPT models is pre-trained by the predicting the next token. And instead, the BERT model is just randomly mask some word in the sequence, and then it tries to predict the mask word there. So this is like a different ways how to pre-train the models. And they usually pre-train these models on very large corpus of data, like hundreds of gigabytes of data, basically like commonly crawled from the website. And then in the fine tuning, which will lead to the InstructGPT, is there are many different ways of fine tuning. Before the GPT or before the zero shot kind of prompt based, like ChatGPT, the prompt based modeling. Previously, is mainly like you need to fine tune it on task A, and you need to fine tune a second model on task B. And that model can only apply to task A, and then the fine-tuned task B model will only apply to task B. So this pre-train and fine-tune like previously typically requires like many task specific training data, and then one specialized model or one task can has its own model. And then when it comes into the GPT-3 world, yes, and then basically the goal becomes that we want to have like one general model that can solve many different tasks all at once. You do not need to fine tune on specific task. So the performance, the goal is like whether we can just get like one pre-trained language model, and we can improve the performance by providing a few examples in the prompt in your input to the model, or do some prompt engineering so that you can directly adapt the the pre-trained language model to the specific task downstream. And then basically you have one model, one set of model weights that can serve all the different tasks. So that's the ideal picture, just like how we are using ChatGPT right now, right? So you just give the instruction, and then you just fulfilling that task as described by your instructions. And then people find that the pre-trained language model is not does not how we can improve this, right? It doesn't always give the best performance for various tasks. And then people say, okay, how can I improve the language model so that it can follow the instruction better? So there are two ways. One way is the instruction tuning. I think the first paper on this is the FLAN model. You can also search about that. The FLAN model is basically they connect a lot of pairs of instructions and answers, like instructions and the output pairs, desired output pairs, and then they directly fine tune this language pre-trained model on lots of tasks. So basically, like the concept is that if that model has seen lots of tasks and seen lots of instructions and outputs, and we hope that this model can also generalize to other instructions and give the desired outputs on unseen tasks. So that's the FLAN model. And then so the fourth option still tries to tackle the instruction following instruction problem is the InstructGPT, where it first proposed to use the reinforcement learning. In this set, it still has the instruction tuning here, and it tries to further improve the instruction fine-tuned model while a reinforcement learning framework. And also it shows that it can improve the human preferred outputs while this framework. Okay, so this is kind of the fine-tuning world. So it still belongs to fine-tuning, and it still belongs to specific like how to let the model follow the instructions. You can just do like a kind of like a brute force, collect lots of instruction outputs pairs and fine-tune the model on that, or you can do a more effective way of like using some reinforcement learning, which I'm going to show next, of how they are using this technology to train that model. And this way, basically, it saves some costs of collecting lots of data, because I don't think like the data set is enough at that time for the instruction data sets. It's not big enough, and it takes a long time to create these data sets. So they find a more effective way while reinforcement learning to connect to improve the model performance. So let's look at the InstructGPT. InstructGPT has 3 steps. The first step, actually, to me, after I read through the InstructGPT paper, I'm feeling like majority of that paper is about connecting data sets. It's more like an application paper rather than like a technology development or new method proposal paper. Is more like an application paper, like using the existing reinforcement learning frameworks to train the language model. So you can see that also like my previous next few slides use quite a large portion as they describe in the paper about how to connect the data set to train the model. So that's why like the step 1 is connect the demonstration data. So the demonstration data is, for example, they need to create, first they need to create lots of prompts. So each prompt corresponds to a task, right? So you can say like explain the moon landing to a 6 years old, and they actually create lots of prompts. And I will show next like where these prompts are created. And then the labelers will demonstrate the desired output. So I think they hired like 40 contractors, and then kind of they, given the task, they will write like what is the desired outputs. And then this data is used to fine tune the GPT-3 model, like the supervised fine tuning, just like the instruction tuning I showed earlier. Right, so given the prompt and the output, the model weight is going to be updated so that it kind of aligns between the input and output. So that's a step 1. Step 2 is they're going to further enrich the data set. Because it takes quite a long time to write the desired outputs, and there are so many different ways to write it, right? So they change the output, the labeler's task as just let the initialized model, say you have a supervised fine-tune model over here, and then it's going to generate many different outputs. For example, you'd ask the same prompt, the model is going to generate like 4 different outputs, and then they ask the labelers to rank like which output is the best according to human preference, and they have set like a different criteria and objectives for human labelers to rank the outputs from the model. And then they train a reward modeling to mimic the ranking system generated by the labelers, right? So this reward modeling will kind of trying to recover the exact or predict the exact ranking of the outputs of the model. And then the third step is like once this rewarding modeling is complete, it's kind of like we have an evaluation system of the LLM outputs. We know like which is more preferred by human with the scalar score. And then the third step is to optimize the policy against the reward using a reinforcement learning. And all the step 3 does not require any enablers, and all this is kind of within the system that you just ask your, say this is the GPT 3.5, and then it will generate outputs, and then it goes to this reward modeling from here, or the evaluation for the evaluation, and then it gives you kind of like a human preference score, and then it tries to update this model so that this to maximize the human preference score, so that the model can generate more and more outputs preferred by the humans. So this is the overall framework. I will show like each step next. And I want to highlight here. So a big bulk of work in InstructGPT is to create the data sets. So the first data set is the prompt data set. So basically you need to connect lots of prompts for the model to, for the labelers to give the outputs, and also for the model to train on those prompts. And the second resource you need is the labelers, right? So labelers will write the desired outputs for the step 1 to do the supervised instruction tuning. And also it's going to provide the rankings to instruct the reward modeling model so that it can learn how human rank like different outputs and align the model outputs with human preference. So first, let's look at the prompt datasets. There are mainly two sources of their dataset. The first is from the labelers directly. So all these prompts are written directly by the labelers. So they can write, basically they ask labelers to write arbitrary tasks so that they cover a diversity of tasks in their prompts. And then they also ask labelers to come up with some examples, right? Some query response pairs for that instruction. So to make it a few short prompts. And also because they have the OpenAI API, like I think based on GPT-3 up at that time, and then they got lots of like use cases according to their API call. But I don't think they can directly use that because I think the user has not consented to use their prompts for training. So basically they ask the labelers to come up with the prompts corresponding to these use cases. So based on their API analysis, they ask the labelers to rewrite those prompts based on the use cases they saw in their OpenAI API call. So this is what the labeler is doing. They have a different source, like the API user prompts. So I think there are like two APIs. So one API is kind of the official, for example, GPT-3 API. There's another API is called OpenAI API Playground. OpenAI API Playground is kind of some kind of pioneer API or product before release. And the users needs to give informed consent to say that, oh, OpenAI can use their input and queries to train their model. So basically they publish an earlier version of InstructGPT, such as the supervised fine-tuned GPT, instruction fine-tuned GPT model on the OpenAI API Playground. And then users give consent to that, and then they start using it and starts provide more prompts for the model training in the next and iterations. So this is some like data size in terms of the number of prompts. For the supervised fine-tuning datasets, for the reward modeling datasets, and how many prompts are used for the reinforcement learning, like the policy updates. So you see like there are different sources, right? The labeler sources and also the customer one is the API, the Playground API user prompts. So for the supervised one, majority are from their labelers. And then the reward modelings, I think you can see that the majority becomes from the Playground API course. And PPO, I think, yeah, so it again becomes mostly like nearly all of them is from their API user prompts. Okay, so that's the prompt datasets. Then they have also done analysis of in their Playground API user prompts. So what are the use cases? Majority is on generation. So basically just like, for example, like brainstorming, like list 5 ideas, how to regain enthusiasm for my career. Like I asked the GPT model to write something. So majority, nearly half of them is on generation. There's also some tasks on open Q&As, chat, rewrite, summarization, and extraction, like just a very small percentage there. So this is some examples of what is like brainstorming prompt, generation prompt, like ask it to write a story and rewrite. Yeah, so here's the summary and this is the outline. So given the summary and maybe ask the model to provide an outline. Or given the outline, ask the model to provide the summary for that outline. for that play. And also in their paper, they have shown lots of examples and templates actually from the user prompts. Like, yeah, basically like brainstorm the ideas for the career and what are the key points I should know when I study in ancient Greece. And also there's like classification tasks, like what language is the code, like generation task, like given the product description, can you write a creative ad? And like the rewrite, like rewrite the following context to be more lighthearted, and the summarization task. So in the paper, in their appendix, they list lots of, basically they show lots of examples from each of their categories in their prompt data sets. Okay, that's the prompts. And then in the step 1, then they just sample a prompt from their prompt data sets, and then ask the labelers to write the desired outputs, and then they update the model weights to fine-tune the model. Yeah, so they fine-tune the GPT-3. So I think they use a smaller GPT-3 model. Yes, I will show next. So they directly use a GPT-3 model as a backbone. And then they train for 16 epochs, meaning that they see the data sets for 16 times. And usually this will lead to overfitting. So people usually report that after 1 epoch, that model is overfitted to that data sets. But according to their findings, they saying that training for more epochs can help both the reward modeling later and the human preference ratings. So they just overfit the model, no matter what, even it's overfitted. But they, in the end, like the final output from the full pipeline, they seen improved performance if you fine-tune, if you overfit the instruction fine-tuning model. So just as I mentioned, right? So this is this data connection, especially this part, right, requires a human to write the desired output. Is quite time consuming and expensive. And usually there's no right answer for the generation task. And instead, we can use this like initialized SFT, like supervised fine-tuned model, to generate the outputs, and then ask the labelers to rank these outputs, which will which is a much easier task, right? So instead of writing a paragraph, you just need to provide a ranking and of the outputs. So it's a much easier task for the labelers. And that leads to the second step of reward modeling. So the reward modeling is basically a model to evaluate the LLM outputs. So they need to connect data. So as I mentioned, lots of portion in their paper is about connecting data sets. So over here, so they sample a prompt from their prompt data sets, and then they ask the model to generate the outputs. And then a labeler will rank the outputs from the best to the worst. And then this ranking is used to fine-tune the reward model. So here is some example. So what they show, I think they also develop some interfaces for the labelers, right? So this is the instruction and this is the output, say, from the model. And then they, for example, this is the summary one, output A. And then they ask for each of the output first, they ask the labelers to evaluate, to give a ratings of the like it score of that output, and also evaluate the output across several dimensions, such as whether this output follow the correct instructions, whether it gives the right output for a customer assistant, whether it contains violent content and harmful advice, etc. So they also evaluate ask the labelers to give individual evaluations for the output. So that's the first interface. The second interface is so there's like multiple outputs to be ranked, and then the user can just pull these outputs and give a ranking, right? So this is the best, rank 1, and this is the worst, rank 5. And also if the user feel like, oh, these two outputs are pretty much similar level of quality, they can still give a tie to these two outputs. So this is how Labors is doing with the data to provide the ranking data sets. In this reward modeling, they actually use a small model. It's not like the biggest one they have that time is like 175 billion GPT-3. They use a 6 billion GPT-3. So GPT-3 actually have a variety of different model sizes. So they choose the smaller one because first it saves lots of compute. And also they find that fine-tuning a large model size can be unstable, and then it becomes like not suitable to be used as an evaluation function during reinforcement learning. So for the reward modeling, they just use a small like 6 billion GPT-3. And then for each of the prompt, they ask the labelers to evaluate from 4 to 9 responses to rank. And this will give like K to the 2, like select 2, like select a pair of responses from the set to compare, right? For each comparison shown to the label. And this will give us this many combinations from the set. And then they train on all the comparisons from each prompt. So each prompt will have this many combinations, pairwise comparisons, and then they train all of these comparisons as a single batch for the to update this 6 billion GPT-3 model. And regarding how they like, what is their objective? Yeah, so so I think this is just like, so this is the reward, right? So this is the final scalar outputs of the model. And we want this reward, this scalar value can reflect the human preference. So if the output, so YW is the response by the model. So if YW is preferred over YL is another response by the model. If this one is preferred over that, and then they want to maximize the scalar values between that, right? So that the scalar output for the likely kind of the preference score for YW predicted by the reward model is much larger than the less preferred output. So this is what is the objective is. So they just want to maximize the reward difference between the preferred one comparing to the less preferred one. Yeah, so that's the only goal in their reward modeling. Okay, if not, then we can continue. Next on the reinforcement learning. So I think right now we have 2 models already, right? So one model is from the supervised fine-tuning instruction fine-tuned model, and then we have reward modeling that can evaluate the outputs. So again, like in beginning is again like a sample, a prompt from the data sets, and then this they call it like a policy model. Can generate the output. So I think the policy model, you can directly use the instruction fine-tuned model as your policy model, right? So that model is already fine-tuned on the prompt and desired output pairs, right? So you can just use that model as your policy model, and then it will give you an output, and then this output will become the input to your reward model, and this reward model will give a reward, kind of like the human preference score for that output. And then the goal of this optimization is you want to update the weights for your policy model so that it maximizes the reward. Kind of like you try to align the model to the human preferences so that it gives or like a high human preference score output. So this is what this reinforcement learning is doing. So they fine-tune the supervised fine-tune instruction model using the PPO. So PPO is not proposed in this paper. The PPO is a proximal policy optimization algorithm. This algorithm is proposed by OpenAI, but it's like a long time before this. like in 2017. I think OpenAI has used the PPO everywhere, including training their LLM. So the key concept in the PPO is they want to avoid having too large of policy updates. So it's basically like going up the cliff to reach the peak, right? And then it tries to limit like how much the policy updates can move so that it doesn't fall off the cliff. Once it fall off, it's going to take a long time for the model to converge and get back to the top. So that's some key concept in that. But if we want to kind of get more details about it, like Hugging Face has a very good deep reinforcement learning course. And the first one covers the PPO algorithm there. And if it's needed, I think we can have another session just focus on PPO. But I want you to remember is like what this PPO algorithm is doing in InstructGPT is trying to like maximize the reward of its output so that it can give more human preferred outputs. So I want to show the objective is trying to optimize. At first glance, it looks a little bit complicated, but I break it down into 3 parts in plain English without any symbols. So what are you trying to do? So it tries to maximize the objective here. First, it's trying to maximize the reward, right? As I mentioned, that we want to maximize the reward so that it can give more human preferred outputs. And then it's trying to penalize the migration from the original supervised fine-tuned instruction model. Because they find that if we just maximize this reward, it's going to overfit to the data set. So this is kind of like a regularization term that we do not want the final policy model to deviate a lot from the initial supervised fine-tuned model. So this is kind of like a regularization term to prevent the overfitting, like overfit the reward. And then they have a third term over here. The third term is they want to prevent the performance regressions on public NLP datasets. So usually when we fine-tune the model on specific task, even though the performance is improved on this task, but the performance on other tasks will kind of degrade during the fine-tuning process. So they add another term here. Basically, this is a pre-trained data sets that includes lots of other NLP tasks. They want to consider those tasks in their fine-tuning process as well, so that the performance won't regress much on other public NLP data sets. So this is the 3 parts, right? So maximize reward, regularization to prevent overfitting to the reward, and also trying to make the model still generalized to other public NLP tasks. Yeah, that's what's the objective is. Okay. And
just one question to the previous session. So I see in end of the paragraph it says that the gamma is gonna be set to 0.
Yes.
For the PPO, it means that it's going to be purely instructive for those cases with the PPO, just to do the instruction. Okay.
Correct. So in their results, they report the performance for both PPO and the PPO like pre-trained weights. Like just like optimizing this or optimizing all together. So they report both results on PPO or PPO with the gamma there. Then let's look at some results. So they have three different model size, like same like with the GPT-3, right? So 1.3 billion, 6 billion, and the largest 175 billion. And then they have the original GPT-3. And then they have like, I guess this is with few shot, like in context prompt, like the GPT-3 with a few shot in context examples, and it improves the performance over zero shot. And then the green one is the supervised fine tuning, right? That is pre-fine tuned on the prompt and desired output pairs. So this is the green one. And then they have the PPO and PPO PTX, right? So this based on like whether that gamma is 0 or not. So the PPO does not care about the pre-trained other NLP task. And then this one with the PTX is also consider the other like pre-trained public NLP tasks with the pre-trained weights. There. So actually, if you see the performance, actually, I don't think they differ much. Like with or without on the InstructGPT data sets. So I think this is the performance is like they calculate the win rate against this green line, basically against these green dots, right? So if it's exactly the same performance, the win rate will be 0.5, like a random guess. And if it improves this one, then it means that it should stay above that. And they even show that with a small model, like 1.3 billion like PPO model, it even has a better performance than this 175 billion model over here, which looks quite appealing that time. And also this is some like qualitative output, like analysis of the output, right? So without this human alignment, the outputs doesn't looks like kind of doesn't follow the instructions of what human expects. And the InstructGPT kind of aligns the outputs better to human instructions. And then they also have compare like the performance to different labelers. So the workers, I think, is like different labelers because they want to make sure that the model is not kind of overfit to specific labelers, and what it shows can generalize to all the human preference, but not to specific labelers. So that's why they also report the performance for the held out workers there. And then they have like two data sets, like one is the GPT-3 data sets, which is less. According to the report, the GPT-3 data sets is through their API is less instructive. Well, the InstructGPT, because they kind of tell the humans to ask instructions to the model, so the instruct data sets is becoming more instruction focused data sets. So yeah, so again, they report the performance across different model size over there. And I think very interesting is to see like on the instruct distribution, like from 6 billion to 175 billion, actually the performance does not improve like by a lot for the held out workers, right? It may mean that the model still is modeling the preferences by the labelers, and increasing the model size does not further improve the performance there. This is what they report, but on the training workers, like, and it still shows improvement, but on the held out ones, the improvement is not that big comparing to the training laborers. And then they also have some like evaluate the outputs across different dimensions, right? Like whether it follows the correct instructions, and whether it follows explicit constraints, right? So in your structure, if you ask the model to like write a light-heart message or write a scientific, write it in a scientific way, right? So you in your instruction, you have some constraints, then they ask humans to evaluate whether the output follows those constraints, and whether the model hallucinate, whether the output is truthful, and also whether they just ask generally, like whether you think that it can be a appropriate output for a customer assistant. So you see that the PPO model, actually this PPO is even better than PPO PTX over here. So the PPO model kind of improves the output performance across a variety of dimensions. One interesting notice is here, like a hallucination part. The supervised fine-tuned model achieves the best hallucination over here, because I think it's more strict, like rigid in the input-output pairs, while the PPO, just cares about the rankings, etc. So it kind of have more freedom to imagine and give a variety of different outputs over there. Yeah, but it's a very interesting discovery in that. And then later they also compare the results with other models, like for example, the FLAN model. So the FLAN is famous for the instruction fine-tuning, and this model is trained on a public NLP data sets. And then they evaluate these models like FAN and T0 models on the instruction prompt data sets. And then so basically it's a Likert score. It's like how kind of a score from 1 to 7, like of the labelers provide, like how they like the output. So basically the FLAN model, even if it has seen lots of NLP variety of tasks, but it's still comparing to follow instructions of SP, like the supervised fine-tuned model, specifically on the instruction prompt data sets, and also the PPO is still kind of lower performance comparing to these two, because these two are specifically developed for the instruction data sets. And then they conclude that the public NLP data sets is not sufficient to train the model to follow instructions. And they say like you still need to dive into your use cases and look at the specific specific use cases and instructions that your use case requires, and it can further improve the performance, which I think it's understandable, because fine-tuning the model on use case specific data sets always help most of the time. And then this is the final implications for alignment research. They also report the computing resources required to train the model. So they train this 175 billion supervised fine-tuning model requires 4.9 petaflops or S days. And training the policy model, like through the reinforcement learning, requires 60 days, comparing to 3,600 to train the GPT-3, the language modeling for the GPT-3. And it shows that like with a much fewer computing resources, it can already like improve the model performance on following instructions. So basically it tells the direction of prioritizing more resources on model alignment rather than training like a bigger, like just using language modeling to train a bigger model may give you a bigger gain. And they also see some evidence that the InstructGPT can generalize the following instructions to settings that don't supervise them in. So basically they can generalize to the unseen instructions and unseen tasks in some settings. And they're able to mitigate most of the performance degradation through those that like pre-trained data set, right, in their objective function. And then they have, I think this is the first time that they validated the alignment techniques from research in a real world application. They also talk about the limitations, right? So right now, this model is determined mainly by the human feedback obtained by their contractors. So as they see in the data, the model like further increasing the model size may not further improve the model performance for the kind of the unseen or new person, right? So because the preferences kind of differ a lot from person to person, so it shows some limitation that this model may overfit to their contractors' preference instead of all the humans' preference, which I think it's it's really hard to model unless you have lots of people using it and providing feedback, just like what we've seen right now with the ChatGPT, right? So once they put this online, like billions of people will start use that, and then that time maybe it's a good time to say they can train a model that can represent the overall preferences of all the humans. And also their models are not fully aligned and not fully safe. They can still generate toxic and biased outputs, and also they still can hallucinate, etc. So these are all like the future directions next in their like following up their paper, right? To even like a violent content, like with or without explicit prompting. Right? The user can ask the model to generate violent content, or even if the users does not provide the instruction in the prompt, the model may still generate violent content just because they have seen it in the training data sets. So I think there will be more like work around how to improve the models, like the truthfulness, unbiased, and also generate more like how to prohibit the violent content on its outputs. So this is the direction they propose when they publish the InstructGPT. So I guess till now, almost a year later, I think there's already lots of developments along this line. Yeah, that's the end of my presentation. So next is how to connect. Yes, so you can use the Meetup discussions and message, or you can message me on Meetup. The recordings will be posted at the Yan AI Talk channel, so including all of our previous sessions, including GPT-3. So that session is there. And I may also like organize the presentations to a blog on Medium.